Good morning. In the third lecture of Unit 1, so we have change of order of integration. So this is the third concept of the same unit, and already we seen double integration and triple integration. So now there is an introduction about the change of order of integration. The change of order of integration generally changes the limits of integration. The new limits are to be examining the geometrical region on which integration is being carried out. That means, so it can be explained by taking an example. So for this I'll not take the first example, it is little bit complicated to understand in the beginning. So now what I'll do is I'll take a second example to explain you. You can see the example. Evaluate integration from 0 to 2, integration from 1 to e to the power x dy dx by changing order of integration. The main point here is changing order of integration means what? So you can see in the example, so they have given dy dx. That means first we need to integrate with respect to y, and later we need to integrate with respect to x. And changing order means what? We will change the order. That means first we have to integrate with respect to x, and next we have to integrate with respect to y. So if we do like that, then are there same limits will be there, or limits will changes? So that is the question. So definitely here limits will changes, so that's why we need a lot of geometrical understanding about the limits. That means what type of curves are there for the given that is limits, so that we need to first understand. So now for this I have written the equation 1. So what they have given, so in that you can see integration x equals to 0 to 2, and integration y is equals to 1 to y is equals to e to the power x dy dx. Actually function f of x comma y is what? That is 1 in this case, so therefore that is only dy dx is there, so therefore it is a very simplest example. So now x equals to 0 and x equals to 2 means what? Now you can see guys, here x equals to 0 means that is y axis. So you can see y axis, so we have drawn in the figure. So that is x equals to 0, and that I have written in the box in a reading, that is x equals to 0. And x equals to 2 means that is also a line which is parallel to y axis but at x equals to 2. So therefore here one more the line parallel line one more the line x equals to 2 which is parallel to y axis is drawn. So these are the two lines we have drawn. That means what? The vertical two lines we have drawn. Now we'll see y is equals to 1 means what? Y is equals to 1 means that is a line which is parallel to x axis at y is equals to 1. So therefore here I have drawn that, and I have written it in a reading, that is y is equals to 1. So that line is y is equals to 1. And one more is that is y is equals to e to the power x, that is exponential function. So exponential function, that is a curve, so which I have shown you in the figure. So you can see that is in the reading y is equals to e to the power x, so that is also drawn. Then we are going to find area bounded by these four curves. That means x equals to 0, x equals to 2, y is equals to 1, and y is equals to e to the power x. So that region R, so I have marked, so that is a shaded region R, so that is there. It is shaded region that as shown in the figure. So therefore we need to integrate that particular things with these that is limits. So now I'll explain you so how that will be done. So in an integral 1, x varies from, so x is varying from where to where, so that one can very easily understand. X is varying from x equals to 0 to x equals to 2, and y is varying from y is equals to 1 to y is equals to e to the power x. Okay, that means x equals to 0 to x equals to 2 means those are the two vertical lines, so that we can fix them, and y is running from y is equals to 1 to y is equals to e to the power x. Solving y is equals to e to the power x at x equals to 2. So what we will get by putting x equals to 2, y we will be getting as y is equals to e to the power 2. So therefore that is here I have mentioned that line x equals to 2 and y is equals to e to the power x intersect at a point 2 comma e square, or 2 comma e to the power 2 we can say. That means x coordinate is 2 and y coordinate is e to the power 2. So that's why here I have written solving y is equals to e to the power x at x equals to 2 gives the point of intersection, that is 2 comma e to the power 2. So now the shaded region R is bounded by, so the same thing that I told you, okay, that shaded region R is bounded by y is equals to 1, y is equals to e to the power x, x equals to 2, x equals to 2. So those are the what, that is 3, because here where they have intersect on y axis, so that is intersecting point, so that's why we are not taking, that is x equals to 0. So in these 3 curves that your shaded region is bounded. So in the next step, so you can see from the above figure, by changing order of integration we get the following limits. So now we are going to change the limits of integration. So now what we'll do is, in the beginning what we did is, for the first integration we have took vertical 2 lines, x equals to 0 and x equals to 2, and now so what we will do is we will take horizontal 2 lines. That means, so already you know horizontal 2 lines are y is equals to 1 to y is equals to e square. Because why it is y is equals to e square is because that whatever dotted line that I have represented, that is parallel to x axis, so therefore it is y is equals to e to the power 2 or y is equals to e square we can say. And x varies from, so now you can see, so if you fixed your that is horizontal lines, then from where to where your x varies, you can see that. So lower curve is, that is y is equals to e to the power x, y is equals to e to the power x means we need to convert them in terms of y varies from y is equals to 1 to y is equals to e to the power x square, and x varies from x equals to log y to x equals to 2. So how that x equals to log y, that is given, that is y is equals to e to the power x is there. If you apply log on both sides, then you will get log y is equals to log of e to the power x. Log of e to the power x means that is x, so therefore y is equals to x equals to log y will get. So therefore now integral 1 can be written here, you can see. So given is so in the LHS side, and so by changing order, here it is in the LHS dy dx is there, and in RHS we will write dx dy. So if you write a dx dy, then so first integral will be with the limits y is equals to 1 to y is equals to e to the power x square, and for the second integral it will be x equals to log y to x equals to 2 and dx dy. So now you can integrate it. So if you integrate, so here you will get that is actually dx dy is there, that means 1 means in the integration of 1 is, that is x. So and limits are from x equals to log y to x equals to 2 dy. So therefore if you put x equals to 2, then it is 2 minus log y you will get, because for lower limit x equals to log y is there, so therefore it is 2 minus log y dy you will get. So now integration of 2 minus log y dy is, integration of 2 is with respect to y is 2y, and integration of log y with respect to y is y log y minus y. So that I think you people know about this, and the limits are from y is equals to 1 to y is equals to e square. So now put upper and lower limit, so you will get 2 into e to the power 2 into e square minus e square log e square minus e square, and for the lower limit minus 2 minus 0 minus 1. So together the final answer is, that is e square minus 3. So we'll get, so like this, so we can solve the problem. So now I'll get back to the problem number 1, because this is the simplest problem I think people might have understood. And now in this first problem it is little bit complicated, so that I need to explain it now. You can see example number 1, integration from 0 to 1, integration from x squared to 2 minus x, that is xy dy, that is dx, by changing order of integration. I think the same example we have solved in double integration. So now we'll see by changing it order of integration, so what will happen to this example. So equation 1, so already people know so how one can allot the limits for the first integral and the second integral, that you know. So now we can see the limits are in a integral 1, x varies from x equals to 0 to x equals to 1, that we know. So that means what? X equals to 0 means that is y axis, and x equals to 1 means that is a line which is here. I have represented a dotted small line, so which is parallel to y axis, and that we can call it as what? That is x equals to 1. And y is varies from y is equals to x square to y is equals to 2x. Y is equals to x square means that is a parabola, so that we have shown. So that is a parabola we have shown, and y is equals to 2 minus x, that is a straight line. So which cuts x axis and y axis at 2. So therefore where it cuts x axis, that is 2 comma 0, and where it cuts y axis, that is 0 comma 2, so that we know. And now solving the equations y is equals to x square and y is equals to 2x gives, we need to solve those two, because point of intersection of those two curves we want. That means the parabola y is equals to x square and the straight line y is equals to 2 minus x, where they will intersect, that we want. So if you solve them, that means if you put y is equals to 2 minus x in this y is equals to x square, so we will get y is equals to 1 and even x equals to 1. So therefore that point of intersection is 1 comma 1, and that is shown in the figure. So now that whatever the shaded region is there, so that shaded region R is bounded by first y axis. Y axis means that is x equals to 0, and y is equals to x square, that is a parabola, y is equals to x square, and next one more that is line y is equals to 2 minus x. That means x equals to 0, that means the region R is bounded by x equals to 0, y is equals to x square, and y is equals to 2 minus x. So now from the above figure we can make a region R into two parts. We need to make this particular region into two parts, because here you can see, guys, vertical lines x equals to 0 to x equals to 1, whatever we have seen in the given example, so that we want to change the order. So therefore we cannot move directly from y is equals to 0 to y is equals to 2, because here the curves are two different curves are there. That is, one is y is equals to x square and the one is y is equals to 2 minus x. So therefore we have to make it two parts. So you can see r1 and r2 I have shown in the diagram here. Here you can very easily understand. So where is the r1, where is the r2? This lower part is r1 and upper part is r2, and that together the whole part is that is r. So now so that citizen will be made into two parts, r1 and r2. In r1, so you can see in r1, so y varies from y is equals to 0 to y is equals to 1, and x varies from x equals to 0 to x equals to, that is root of y. Why it is root of y? Because y is equals to x square is there, that parabolic curve, so therefore x becomes root y. So therefore in the region r1, y varies from y is equals to 0 to y is equals to 1, and x varies from x equals to 0 to x equals to root y. And in r2, in a similar way, in r2 you can see y is running from y is equals to 1 to y is equals to 2, and here x is varying from, that is y axis means x equals to 0, and x is varying from x equals to 0 to x equals to that is, here you have y is equals to 2 minus x. So therefore that is a straight line, so you have to convert it in terms of x. So therefore you will get x equals to 2 minus y. So therefore both the this one I have written. That means in r1, again I'll explain. In r1, y varies from y is equals to 0 to y is equals to 1, and x varies from x equals to 0 to x equals to root y. And in r2, y varies from y is equals to 1 to y is equals to 2, and x varies from x equals to 0 to x equals to 2 minus y. So therefore equation 1 can be rewritten as, so because we want to change its order of integration, so therefore we can write it like this. That is two integral signs, y is equals to 0 to 1, y is equals to 0 to 1, and x equals to 0 to root y, xy dx dy, plus y is equals to 1 to 2, and x equals to 0 to 2 minus y, xy dx dy. If you integrate these two integrals with respect to that is x first and y next, then finally see here you will get that is 3 by 8 as an answer. So guys, like this one can very easily find that is order of sorry we can find we can evaluate, and that is double and triple integration by changing its order. Thank you. So we'll see in the next class the next unit.